Okay, let's give you guys some more practice. So find the limit of this as x heads towards 0. So press pause and have a go. Okay, so to do this, we need to turn this into a series. We need to turn this into into this block, and we need to turn this into this block. So here we've got x squared. So we've got to put this x squared into this x here, So we've got to put x squared. So we've got to put x squared into this x here. So that will then give us this, and then now it's this multiplied with this. That will then give us this. So looking at this, hang on. Looking at this, so sine x squared equals this whole thing here. But we're interested in sine x squared over x to the power 4. So we're interested in this thing over x to the power 4. So that would then be the same as you getting 1 over x to the power 4 multiplying with this whole block. So you can now don't forget when you look at this. So when you have one block multiplying a summation, you've actually got this something plus another thing or minus plus another thing or minus another thing. Then you can actually push push this thing into the summation. You can actually push this whole thing into the summation. So it will become this x to the power 4, and then now if you look at this, it would simply be this take away this. So that would be so here you've got 4n plus 2 take away 4. That would be 4n minus 2. Well, this whole thing here equals this. Okay, so now we need to look at cos x. So cos of x equals this. So cos of x over x squared will be you doing this. Will be you doing this. Hang on. It would be you doing this x squared. So it would be this take away this. That would then give you this thing here. Okay. Well, this whole block here equals this. So going back to our original problem, we are trying to work out the limit of this. So this whole thing here equals hang on, let me think. This whole thing here equals this, and then this whole thing here equals this. So we've got to get this block. We've got to get this block. Take away this block. So we've got to get this block. Take away this block. But let's break this up so that we can see the first few terms. So when n equals 0, put 0 into here. So we know it's going to be a positive. Put 0 into here. So this will be 1 factorial. So that would be 1. Put 0 into here. 4 times 0 will be 4 times 0 will be 0. Take away 2. That will be x to the power of minus 2. X to the power minus 2 is the same as 1 over x squared. So that would be this. That's your first term. And then when n equals 1, put it into here, put it into here, put it into here, it will be this. And then the rest, you can just bung it into here. But by the way, you don't need to break this up, but I'm just doing it to illustrate to you. You can actually push this into here and start at 1 rather than 2. But the reason why I'm breaking this extra term is it's just I'm just trying to illustrate that you can do that. And then now break this up. Look at the first few terms. So when n equals 0, put into here, put into here, put into here. The first term will be this. And then when n equals 1, put it into here, put it into here, put it into here. It will be a half. And then the rest will be when n from n equals 2 all the way to infinity. So the rest will be this. So when you get this, take away this. So when you get this thing, take away this thing, then you can see that this thing will cancel out with this thing. And then later on, when you take the limit as x tends to 0, this thing here is going to go to 0. And then everything else everything else in here, x heading towards 0, everything else will be 0. So if you look at this, as x tends to 0, this whole thing here, well, everything here will be 0. The reason, so going back to here, we are trying to work out the limit of this. So we've got to get this, take away this. The reason why we need to break this up, the reason why we need to break this up as one block, take away another block plus the rest, is because the reason why we need to break it up is so that we can get these two to cancel each other out, and then you're going to left with this constant here. Well, anyway, this thing take away this thing, that will be this thing take away this thing, that will then give you this. That will then give you so this thing take away this thing, that will be this whole thing take away this plus this take away this, and so on. These two will cancel each other out. When you take the lim as x tends to 0, this is going to head towards 0 anyway. This will head towards 0. This thing here will head towards 0. You're just left with this block here, a half. So the limit of this as x tends to 0 is a half. And by the way, you trying to evaluate as x heads towards 0. If you go back right from the start, go back to the start. Hang on. So we needed to break this up. We needed to turn this into a series. We needed to turn this into a series. Well, if you look at this here, x is valid. X is valid for all values. For x can be anything on the real number line. So you heading towards 0 is fine, because this thing here works for all values of x. And then you turn this into a series, or you turning this into a series, you turning this into a series, then this is also valid for all values of x. So as you head towards you heading towards 0 is fine, because this works for all values of x, for all values of x. So it's fine. So you heading towards 0 is fine. Well, anyway, overall the overall limit is a half. Okay, is a half.